Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video.
Now let us solve this problem, which is very simple looking, but it is a tricky problem. It's a tricky question. And let me tell you, before even reading this question, that there is slight incorrection in this question. There is a slight mistake in this question. I would be very happy if you could recognize that mistake. Don't worry, before solving the question, I will tell you what is that mistake and I will correct it. But it would be great if you can locate that mistake. The question says that a railway reservation block has 20 counters. A railway reservation block, we have seen there are different counters. So it has 20 counters available. The mean arrival rate is 150 per hour. Obviously, customers or those who want to book the tickets will be coming. The mean arrival rate is 150 persons or 150 people per hour. And service time is exponentially distributed with a mean of 5 minutes. The service time it takes for the server to process their request and do their job is 5 minutes. Obviously, it is per person. Okay, so don't think that is a mistake. It is 5 minutes per person. To keep the waiting time in queue limited to 15 minutes, determine the number of counters to kept open. So it has 20 counters. Not all require to be opened. Depending upon how much crowd is there or how much waiting time you want to keep, you can decide to open more or less number of counters. The last statement of the question is saying that to keep the waiting time in the queue limited to 15 minutes. So waiting time in the queue should be 15 minutes. Determine the number of counters that are needed to be kept open or to be kept open. This is the question. In this question, if you start solving it, you will obviously be able to solve it. It is not a very difficult question if you start solving it. But I said it's a tricky question. There is something in this mistake, there is something in this question which is a mistake. And I will tell you that how different problems can be made using that concept. Now, before I solve this question and I point out the mistake in this question, let me tell you something which will help you in many questions where number of servers or number of counters calculation is required. In this case, consider that there is a college building. This is a different case, a separate case than the given question. Okay. Suppose there is a college building and there is a burger stall nearby. The students of the college, obviously when they go out or when they feel a need or a want to eat burgers, they eat the burgers. But it depends upon the college duration. When the classes are conducting, who is the faculty, whether you are bunking the classes or not, when the classes are going on, when the recess time, when is the college gets over, right? All these factors will decide that how many of students will gather at the burger stall and eat the burgers, right? There will be some hours in the day when the classes are going on, faculty is very strict, there is no bunking, everybody is sitting in the class, then there will be 0 people, 0 student on the burger stall. But obviously there will be the duration when the college is over, and in those times maybe the number of students who will be eating the burger will be very high than 10. The lambda value is 10 per hour, means on an average This number is the average or mean value of how many of the customers are coming to get the burgers, to get the service. That is not the exact value. Exact value can vary. It can be as low as 0 and it can be very high than 10 as well. Right or not? So the arrival rate is calculated by how many people are coming divided by the number of hours during which you are doing the analysis, right? Maybe per day, how many customers are coming in 24 hours, so we'll divide it by 24, right? We have seen this in the previous question, in the previous example, we have seen exactly this situation, right? So this arrival rate what you are getting is the mean value, which is very much fine, because whatever analysis we do, majority of the analysis that we do in queuing theory is average value, mean value, most probable value, probabilistic values, right or not? What is the average length of the queue? What is the probability of 5 customers in the queue? What is the most probable waiting time? All these things, if you look at, are the average probabilistic values, which are not exact values because you cannot predict it, right? You cannot exactly say that every hour 6 people will come. Nobody can do that. It's something which keeps varying. That is why we have distributions, right? Poisson distribution, we have exponential distribution, we have, because it's a probabilistic study. But whenever you get a question where number of servers or number of counters are needed to be calculated, that you cannot have a probabilistic value or an average value. For example, in this question, let's come back to this question. The question of railway reservation. The question is asking you to determine the number of counters to be kept open. It is not asking you the average number of counters or the most probable number of counters, right? It is asking you the exact number, which is logical, very much logical. Suppose this is a real world problem where some company needs to decide, or some organization needs to decide how many counters to be kept open, right? So obviously they cannot have an average value. They need to know the exact number. Based upon that, they will plan the workload of their employees, that you 4 or you 5 have to sit there, rest will go will work at the other place or do some other work. They cannot have some average value. They cannot plan their work based upon the average value. They need to know the exact number. Based upon that only, they will open the counters, or they will design the overall structure, overall place, right or not? So when you get a question where number of counters is asked exactly, and you do the calculation of this arrival rate based upon the average value, you are not going to get the right answer, because the arrival rate that you are taking is a mean value which can go high, and you need to keep the waiting time limited. Waiting time is to be kept limited to 15 minutes. It should be limited to 15 minutes even when the arrival rate is highest. Not for the average value, but for the higher value as well. Yes, it may be possible that when there is no arrival, then the people at the server are sitting idle. The server is idle, which is fine, because when server is idle, then also theoretically you can say that the waiting time in queue is limited to 15 minutes, is less than 15 minutes, right? Because there is no queue. So automatically this sentence is not going to be applied there. So it is acceptable that some of the counters may not be used all the time. They may be sitting idle, but in the peak hours, they should be able to ensure that waiting time is limited to 15 minutes. But when you do the calculation based upon average or mean value, you cannot say it. You are not even prepared to handle the peak arrival rate. You are only doing the calculation for mean arrival rate, and you are expecting that the waiting time in the queue will be limited to 15 minutes in peak hours also. How do you know the value of peak hours? How much arrival will be there in the peak hours? How do you know? It is the average value, 150 per hour. It can range maybe from 140 to 160, or maybe it can range from 100 to 200. So if you are just designing for this, it will handle it for the lesser crowd. But when the crowd start getting increased, especially in peak hours, how can you ensure that this time will be limited to 15 minutes? You cannot ensure it. That is why this is the mistake of the question, right? Here, the mean arrival rate cannot give you the correct answer. In the question, in the exact question, here we should have the peak arrival rate or the highest arrival rate and not the mean arrival rate. PEAK, peak arrival rate. So if you get a question like this where two different values are given, mean arrival rate is also given, peak arrival rate is also given, to do the other calculations that we have already done and we have already learned, the average number of people, the probability of this and that, for that mean value will work. But to find out the exact number of counters, mean value will not be a safer design, right? We have studied about design, machine design. This is the basic fundamental of machine design, right? Always consider the worst loading, highest possible stresses that can act. According to that, we do the design. We don't design it considering the safe situation, right? This is something the very much fundamental of machine design, which I have taught you throughout the subject. Here also same thing is applicable. You see how they are related. Industrial engineering, machine design, as such you cannot relate them, but this is something which comes as the beauty of mechanical engineering, how different things, different subjects can be related together. So here also the peak arrival rate is to be used. If a question comes which give you mean as well as peak arrival rate, for other calculations use the average value, mean value. But to calculate the number of stations, servers, counters, use the peak arrival rate. Is that clear? So that value, peak arrival rate, is the correct value and not the mean arrival rate. So lambda for this question we will consider 150 per hour. The service time is distributed with a mean of 5 minutes. So one person on an average gets serviced in 5 minutes. So in 1 hour, how much time, how many of them can get serviced? Exactly 12 people, right? 60 minutes in 1 hour, 5 minutes, one person. So total 12% on an average in 1 hour. So the value of mu is going to be 12 per. The waiting time in the queue should be 15 minutes. Obviously you need to convert that into hours because all other units are in hours. So this is going to be 15 divided by 60. Correct? 60 minutes in 1 hour. So it is 1 by 4. 15 divided by 60 is precisely 1 by 4 hour. So this much is the waiting time in queue. Now comes another interesting part. In this expression, many of you would want to put the value of lambda as 150. But if you do that, what are you calculating? If you do this, you put this value as 150, how can you calculate the value of the number of counters? And think conceptually, if 150 people are coming every hour, this is the net arrival rate, that in peak hours how many people are coming per hour. That is not the arrival rate per counter, that is the total arrival rate. In totality how many of them are coming, obviously they will be divided at each counter, right? So the arrival rate per counter is going to be 150 divided by n. So the value of lambda, this value is not the value of lambda per counter or per server, it is the total value of lambda. For this calculation, this is the lambda per server and not the total value. So here lambda will be 150 divided by n. Here also lambda will be 150 divided by n. So the value of n when you solve it comes out to be 16.667, means you will be needing 17 counters because number of counters cannot be a fraction or a decimal. You either need a counter or you don't need a counter. Yes, the counter that you are going to add, which is not going to get utilized, the 17th one will not be totally utilized like other counters. But since the value is 16 point something, more than 16, so number of counters will round off to the next integer. Please keep this thing in mind. And the thing that I told you regarding the peak arrival rate, some of you may be thinking that, sir, why then we are taking the mean service rate? Why service rate we are not changing? We are taking the mean value. Look, the service rate, how many counters you need, depending upon the crowd, is not going to affect the service rate. Service rate depends upon how effectively and fastly the person sitting on the counter can do his job. There will be some person sitting on the counter, right, reserving the tickets. It's a railway reservation counter. Now, whether there are two people in the queue or 20, or whether there are 5 counters or 20 counters, how much time it takes for any given person who is at the server, that is not going to get affected by the length of the queue, by the arrival rate, by the number of counters. That is not going to change, right? That is why it is very much logical to use the mean value there. And obviously question has given us the mean value directly, right? Here peak value is given. I modified the question and put mean here just to tell you this concept. But here mean value only is given, so obviously you have to use the mean value. But what is the concept behind that? That I have told you here. So in this question we got to know about 2-3 important concepts that you need to know to solve any question regarding number of counters requirement.